the sort of Hugging Face ecosystem is roughly split, I would say, in a couple of areas. So one is, of course, the open source libraries. There are libraries like transformers, which are kind of like the main backbone of what we do. And there are many ways to contribute, ranging from, squashing bugs to adding a new architecture.
My name is Sophia Yang. I'm a data scientist, and I also organize this book club. We read one data science book per month. And Lewis, would you like to tell us a little bit about yourself?
Yeah, sure. So I'm an engineer at HuggingFace. I started off working in the open source team, primarily looking or contributing to transformers on the topic of optimization for inference. And I also helped co-develop a course we have on NLP and transformers, which is kind of like a precursor to the book. And more recently, as I was saying at the start of this chat, I've kind of switched gears into the research team to sort of help on the engineering side of things around these topics of reinforcement learning from human feedback, and more generally, how do you scale up to the kind of 50 billion parameter plus range where the sort of, interesting phenomena seems to appear. Before that, I was a total nerd doing theoretical physics. And I spent several years after my PhD as a researcher studying kind of particle collisions at the Large Hadron Collider. And it was from that experience I stumbled into machine learning when a guy in my office was like, hey, look at this piece of TensorFlow code I wrote. It can basically beat you and every other physicist at classifying different types of particles. And I was like, okay, I should probably pay attention to this, and kind of got hooked. And I started out like many other people did at the time with Andrew Ng's classic course where you do like machine learning with like Octave, and eventually upgraded to TensorFlow 1. And yeah, now I'm in the land of PyTorch where life is a little bit more easy to work with.
You just answered one of my questions. Perfect. Thank you. Yeah, I was wondering what's your transition from physics to computer science, Hugging Face. It's all incredible. So I want to give it a chance for our book club members to introduce themselves. If you're shy, feel free to introduce yourself in the chat. Don't have to talk, but yeah, who wants to go?
Nice to meet you, Luis. My name is Danielle. I am a software engineering manager. Currently, my team is working mostly with data engineering, but we also have some data scientists. And I mean, when the guys picked like your book, like Book of the Month, it was a blessing for me because we are tackling some kind of issue related to NLP, and my knowledge in NLP is like bag of words and n-grams, and it was really helpful, and I really appreciate like reading your book. It gave me so much clarity. So yeah, thank you for that. Now I know, okay, we have this PII problem, and we have like, okay, some kind of NER model that maybe we can use to do some anonymization, and I don't know, the encodings look up for some kind of nearest neighbor search, and then like reducing the document space to do some kind of Q&A. It was really great,
Awesome.
You have no idea how much you guys helped me. I'm really grateful that I read your book. Thanks a lot.
Thank you very much. In fact, the sort of story of the book is that I started out learning transformers from the PyTorch pre-trained BERT, because at the time I was working as a data scientist. And I remember looking at this and going, oh, I have no idea what's going on. And then Leandro, my colleague, was like, hey, let's like look into this. And then after a while, there wasn't many opportunities or many things available. So there was like Sasha Rush's classic, the annotated transformer, which basically derives a transformer kind of from scratch. And then there was like Jay Alamar's really great blog posts about like the illustrated transformer. And because we were more practitioners, we wanted to do something that was helpful to other data scientists. And so we said, hey, let's like write a book about this as a kind of forcing function to really learn stuff. And my wife was like, oh, you're always talking about Hugging Face and transformers. Maybe you should like check with them that they're not writing a book, because it will suck, right, if you do all this work and then, they release the book. So I just sent Tom Wolfe an email like out of nowhere and just said, hey, we're these two random data scientists writing a book. Are you interested in, co-authoring it with us? And he was like, yeah, sounds cool. And that was like, one of those things in life where you think no way on earth is Tom going to reply to this random email, but I'm quite happy he did.
And at the time you were not even working at a HuggingFace?
No. It was, we were both working for Swiss companies.
Oh,
So I was
wow.
working for a Swiss telecom company and Leandro was working for a Swiss insurance company. And yeah, it wasn't even planned that we would, join HuggingFace because, for a long time, it was like, okay, I'm not going to leave Switzerland or something like this. And so I think the pandemic kind of enabled this ability for people to work, across countries. And yeah, one thing led to another.
Wow. And now you're both at HuggingFace.
Yeah,
That's incredible.
Yeah. We've been there for nearly 2 years now. So
that's such a great story. What's the process of writing this book? It's very, very technical. Every chapter is a great read. I feel like this book takes me a lot longer than other books we have been reading in the book club. So it must be really a long time for you to write as well, I could imagine. How long did it take for you to write it?
Yeah, so it took us a year, I think. Yeah, maybe a year and a few months from like the very first, piece of code we wrote to the final thing. But the most time-consuming part is not writing; it's actually making a use case that works. So because we were taking this like very practical approach, behind every chapter, there's maybe 1,000 failed experiments. So in a sense, it was like doing data science, right? Like you have an idea or you have a problem you're trying to solve, and you have to iterate many times to get something that kind of works. And that was the most time-consuming thing. And then I would say the writing itself was roughly split between the authors. So we would, say, I'll take this chapter and then send a draft about a month later, and then a few weeks later we'd go to O'Reilly and get it back. So the hard part in this was because we chose to have code. We made our lives 1,000 times more difficult, but hopefully this turns out to be more practical for other people. So it's not just, theoretical.
Yes, I really appreciate you have the code there so we can try it out. And also a GitHub repo, very helpful.
Yeah, that's right.
Yeah, I think except for one of the chapter where you trained for like a couple of weeks, that one we couldn't try.
Yeah. Unfortunately, that one is quite expensive. You need $50,000, I think, to train that model. But still, at least the code is there if you want to adapt it to your own application.
Yeah. Thank you. Yeah, we got a book club member introducing himself here in the chat. Hello. Not sure how to pronounce your name. I will not try to embarrass myself. Okay, we have several questions. Does anyone wants to start with your questions, or should I start?
Okay, I can start with mine. Hi, I'm Peter, and I have a question. Actually, given all this stuff that happened in last half a year, what would, if you were to write another chapter of the book, what would it be? Maybe it's something totally, because GPTs are not that new, maybe, but maybe there is something you would like to add, like another chapter. What would it be about?
Yeah, that's a great question. We were lucky, I think, that we released the book before ChatGPT came out. And in fact, before diffusion models came out. So I think those were the two big changes in the landscape of what's possible with like generative models that we didn't even touch really in the book. And what I would probably do if I was adding another chapter would be to focus a bit more on like multimodality. So the idea that like it seems that the future of the field is heading in a direction where combining text with other inputs like images and eventually, I guess, audio and video will come soon, seems to be where the most kind of progress is. And having some examples of that, I think, would have been quite nice to show. And I think the other element would have been this sort of reinforcement learning from human feedback business that is powering sort of ChatGPT and other models, it's also kind of old. Like OpenAI first started exploring this in like 2017, and 2019 was roughly when they got it to work with NLP. And so, you know, we knew about these things, but I think none of us really had like our eye on the thing of thinking, okay, that really is going to be the secret magic or the ingredient that is going to transform the quality of the language models. And so probably that would be like another thing I would mention. Maybe not yet able showing code and how it works, because right now I'm doing these experiments and it's very, very expensive. Mostly because the compute and the data collection is itself quite expensive, but still showing the actual process and the kind of difference in quality that one can get, I think that would be a nice thing to show.
So along the same line, which chapter would you change? Anything you would write differently?
Let me think about it. So yeah, maybe the chapter, let me think. So there's two areas I would think about changing. We have this chapter on pre-training, which is this where we train a kind of code generation model. And at the time, we used just like kind of conventional tools. So things like the Accelerate library and transformers. One of the kind of interesting developments in the last year has been the kind of realization that there are certain tricks one can use for pre-training to make it more efficient. So one of the sort of most impactful changes is something called multi-query attention, where in this attention mechanism that we sort of discuss in one of the earlier chapters, we talk about how you've got these kind of like three matrices. You've got this query matrix, a value matrix, and a key matrix. And this kind of is how you compute these attention scores. And one of the researchers at Google realized you can make this dramatically more efficient if you only just basically keep one of these query matrices. And what this lets you do is it lets you train generative models and evaluate them in a really, really efficient way. So the model we train in the book, if you want to evaluate it on a benchmark for code models, it takes you maybe 2 days of GPU training, which is quite expensive, or sorry, GPU inference, which is quite expensive. And with these new techniques around attention, you can do it in like 10 minutes. So it's a dramatic improvement in like kind of sort of optimizing your code for training efficiency and inference efficiency that I think would be nice to have included as a way of showing people like, you know, how you can do things in the real world at scale. But yeah, that's,
Wow.
you know, it didn't exist when we started, so can't blame me for that.
That sounds fascinating. Where can we learn more?
I can dig up the link actually, if you want.
Oh, yes, please. Thank you.
So it's a paper called Fast Transformer Decoding. I'll put it in the chat.
Is there a coding example on HuggingFace somewhere?
Yeah, let me dig it up. So I know there's so Leandro, my co-author, he went on to form this thing called Big Code, or the Big Code project. I don't know if people have heard of this. I'll put that in the link as well. And this is essentially a project to try and replicate OpenAI's Codex model. So OpenAI has Copilot, which is like the product that you may have seen in VS Code and GitHub. And the kind of original model that they kind of discussed in a paper was called Codex. And so this Big Code project is an initiative to try and essentially replicate Codex for Python. And in this project, this is where they realized that if they introduce this multi-query attention, then they're able to get, you know, very, very fast evaluation. I'm trying to dig up the part of the code, but yeah, I can't find the exact class. But basically, if you look inside this Big Code repo for Megatron, you'll find it there.
Okay, thank you so much.
Yeah, sorry to get like super technical, super fast, but yeah, if
No, we have very technical audience here. Sorry, Peter, I think I interrupted your conversation earlier. Do you have other questions?
Yeah, I was just saying thanks for the answer before. Yeah, but I have like one more question. So given how fast everything's happening, actually, what skills should we get to be able to contribute to Hugging Face? Because as for now, for me, I know PyTorch, but it looks like most of the stuff made with PyTorch is done. And now everybody's using like this JAX or, you know, stuff with. Still, I have to learn this, and when I will be ready to contribute, something else will be used.
Yeah.
Right? So what actually to learn, to study, to be able to contribute to Hugging Face, to the whole open source ecosystem?
Yeah, that's a great question. So full disclaimer, I don't know JAX either. So I can't make comments one way or the other in favor of it or not. But I guess what I can say is that in general, there's always like, let's say, frameworks like for deep learning, and there will be another one or many more coming after JAX and so on. And my personal experience has been it's better to know one really well and really focus on that, because generally speaking, learning, once you know one very well, learning the others is like, you know, a little bit like if you know Spanish, you can probably speak Italian a little bit, and, you know, the neighboring languages are not so different. Regarding the ecosystem, I mean, the sort of Hugging Face ecosystem is roughly split, I would say, in a couple of areas. So one is, of course, the open source libraries. And in that respect, there are libraries like transformers, which are kind of like, let's say, the launch or the main backbone of what we do. And there are many ways to contribute, ranging from, you know, squashing bugs to adding a new architecture. So, for example, a lot of research labs like from Microsoft and Facebook, they typically release like a model and they say, hey, check out our super cool model, but it's usually implemented in their framework, like, you know, Fairscale or JAX, for example. And a lot of the sort of users of transformers are primarily PyTorch users. And so porting that kind of pre-trained model into transformers with like a PyTorch modeling file, that's one kind of usually like high impact contribution, especially for models that people are very excited about. And then, you know, outside of transformers, there are other libraries, like, for example, we have like this datasets library, which integrates with the hub to enable loading and processing of datasets. We have the Accelerate library, which is not really specific to a type of like framework, but more a way of simplifying like distributed training. And as with most open source projects, it's a little bit up to you, like what you want to contribute to. And my personal experience has been that when you're trying to solve a problem, like in your day job or in something like that, that's often where you have the strongest pressure to like make something work. And that gives you like the sort of push to contribute back. Like if you want to make, I don't know, Accelerate do something and you're like, oh, it doesn't do it, then typically then you can sort of, you know, propose it as a feature. And if it's approved, then that way you kind of contribute. And then the other side of it is we have the hub, which is where people share their models and their data sets, and more recently, like their demos. And I think here, I expect in the coming year, there to be like quite a large explosion of like models and data sets around the building blocks of ChatGPT. And we're already starting to see the start of that with this Llama model. I don't know if you've heard of this, but yeah, Facebook released a model called Llama. And shortly after that, some researchers at Stanford generated a data set called Alpaca, which is essentially synthetic instructions and demonstrations from ChatGPT, or one of the sort of instruct models from OpenAI. And then people have now gone berserk training lots of Llama models on these types of data sets, because the quality of the instructions or the generations of these models is very good. So when you chat with one of these like Alpaca models, it's almost like chatting to ChatGPT. I mean, it's inferior in many ways, but it gives you that kind of magic feeling of like, oh, this thing kind of understands a little bit what I'm talking about. So one thing I could imagine people contributing to would be creating kind of like these types of models, but potentially in non-English languages. So, you know, can you create like a kind of like an alpaca type model in German, Spanish, Italian? I think that's where a lot of value is, because, you know, many of these like sort of non-English languages, I mean, they still need to do NLP, but most of the resources focus on English. And then the other side of that is around like community. So HuggingFace typically has several events throughout the year, ranging from, you know, training on TPUs with diffusion models to, you know, conventional, like, you know, audio type things. And taking part in those is often one way to contribute and learn usually quite a new set of skills. If you want to, for example, train on TPUs, you get to learn how that works. I don't know if that answers exactly what you had in mind. Was it roughly what you were thinking of, or were you thinking more broadly, like what does the future look like when we've got, you know, ChatGPT writing our code for us?
Yeah, it was definitely part of the question. I was pretty, like the framework part, it was pretty informative for me, just, you know, to focus on one. This is a great piece of advice. And what about other like programming languages? Is Python enough, or should we try to learn CUDA or, you know, Triton or C++? Or maybe JavaScript, right? To be better at writing, like editing spaces, you know, maybe a little bit on that.
Yeah. So I think my advice is going to be biased, like all advice. So I only know like maybe 2.5 languages, so Python, C++, and a bit of Java. So I have no idea about front end, and I've always stayed away from it. But from what I can tell, maybe the most relevant language for machine learning outside of Python seems to be Rust at the moment. So like, I don't know if you're familiar with Rust, but roughly speaking, it's like a very performant language which avoids some of the, you know, gotchas in C++ with memory. And for example, large parts of the HuggingFace ecosystem are written in Rust. For example, the tokenizers library, its backend is Rust. And some of the tooling that we're building in the next probably few months is going to involve some elements of Rust as well. If you want to scale this like RL stuff to like really large models, you start having to worry about like asynchronous kind of messaging, and yeah, but that Rust is the thing to do. So that would be maybe the other thing to think about. But my personal experience has been learning a language for the sake of it. For me, I just don't remember stuff. Like it just goes in, and then 1 week later, I've forgotten it. So ideally, you would like to find a project or a need where you absolutely need to do that, and then that really, you know, is the forcing function to master it. But yeah, I feel Python is going to stay for some time, and I don't think you should worry maybe too much about the type of language itself, unless you really have a need for high performance.
Okay, thank you.
Sorry, yeah. So thank you very much for your detailed answers. I was wondering, just to piggyback on this question, is TinyML, this idea of sort of trying to embed machine learning in systems where you don't have access to lots of GPUs, or you want to be running these models on a consumer hardware, is it going to be a focus for HuggingFace? Because I've seen that recently. You mentioned Alpaca. I've seen the low-rank adaptation method where you can sort of train these models on a single GPU. There's also a C++ification of many models, like Llama, for example, llama.cpp, whisper.cpp. And I think that people are really interested in these things because they want to run their models on their own, like, crappy hardware. My hardware is very crappy. I only have a single Mac. I don't have any GPUs or anything. And so I was wondering if it would become a focus for HuggingFace as well, or yeah.
Yeah, I think maybe not a big focus, but definitely something that some of our team members are looking at. So one of my colleagues, he created, or he piggybacked on this Llama CPP, and he created like a Bloom CPP.
Oh, wow.
Bloom is like one of these language models that we have. And I kind of hope that all these like llama.cpp things become the new Doom. Like, can you run Doom? There's this joke, right? Can you run Doom on like, your phone? Can you run it on your, pregnancy test type stuff? And maybe, the next frontier is like, can you run some language model on these devices?
Can you run Bloom on your Apple Watch or something like this?
Exactly. And another area where there's definitely been a lot of work done at HuggingFace has been around diffusion models. So again, you can always, do inference on some big fancy GPU for like stable diffusion, but people typically want these on device because, maybe you don't want to have to send your photos somewhere. And maybe you just want it to run on your laptop, right? Like you just don't want to have to keep, paying for these like costs. And so there's been quite some work from one of my colleagues called Pedro on, making this work on like Apple's neural engine and stuff like that. So I think there's like quite exciting elements there. I think the other question of like efficient fine tuning, I also really think this is going to be a big topic this year. So just for everyone else who's like not sure what we're talking about, in the book, right, we talked about fine tuning a lot of pre-trained models. And when we do the fine tuning, we essentially would take like a pre-trained model, you would slice off the head of that model, which was typically, trained for say next word prediction, next token prediction, and you would then take your, task specific head and then train everything end to end. And one of the kind of realizations in the last, say, year or so has been that, when you get to very large models, this gets very, very expensive. So if you imagine trying to fine tune like a 20 billion parameter model or even more, doing that whole fine tuning process is going to require many, many GPUs, and it's going to typically require you to do some complicated things like splitting the model and the optimizer and all the stuff across multiple devices. It gets very messy. And so a lot of different researchers have come up with techniques where you basically take the pre-trained model and you freeze it in some way. And then what you do is you kind of insert these things called adapter layers. So these are like little neural networks, like little feed forward networks that are inserted at various parts of the original transformer. And then you only train those. So everything else is basically kind of frozen, and you just get kind of fixed embeddings from those frozen parts. But these adapter layers are the things you train, and they get that information from the frozen backbone. And this is very efficient. It means you can train maybe 1 million parameters or 2 million parameters on top of like a 7 billion parameter model, and you get a really, really good performance. And in particular, what's very exciting about this is it allows you to essentially have one model, like your backbone model that you have to store on disk. And then everything else is like an adapter that you can just switch in and out. And so if you're thinking about deployment, and I've got, maybe I've got like, I don't know, 3 different tasks, like, an identity recognition, text classification, and question answering. So traditionally I would need 3 different models, like, maybe 3 BERTs, but 3 quite different BERTs. And with these adapter approaches, you can basically have one like BERT base or whatever the encoder backbone is. And then you have these like adapters, and these adapters are very small. So for deployment purposes, you just have to switch the adapter, and it's only switching, 1 million parameters versus having to really host and store, maybe 3 7 billion parameter models. And just like this week, I was experimenting how far can you push this, and I was able to train or fine tune like the Llama 65 billion parameter model on one A100. So, okay, it's a big fancy GPU with 80 gigabytes of VRAM, but still the fact that you can do a 65 billion parameter model on one GPU, hopefully over time the price gets cheaper, and then, this will be kind of commodity hardware. So I think that's the most exciting area for practitioners this year.
So what was the task you fine-tuned it for?
Instruction tuning. So I'm trying to create instruction models like everyone else.
Okay. Wow. Okay. Yeah, thank you.
In fact, there's a really cool paper. I'll see if I can find it. So there's a nice survey of all these methods. Let me just dig it up. And it's got, let's see. It basically gives a very nice overview of the last like kind of couple of years of these efficient techniques. And at HuggingFace, one of my colleagues has created a library called PEP. And this library basically integrates with transformers, and it does all of these like fancy techniques where you basically, you know, only train a small number of parameters. And yeah, if you want to try it yourself, it's quite nice.
Great. Thank you. Yeah, so it's already possible then to do this in HuggingFace. I didn't know. Oh, that's great. That's great. Because I was wondering, I was thinking maybe it's going to become more and more common. So maybe HuggingFace, it would be great to have something like this on HuggingFace. I didn't know it was already possible. You guys are so quick at implementing things. It's crazy.
Well, we got a question from the chat. Sam asked, I was wondering if you could comment on fine-tuning LLMs versus using zero-shot and few-shot.
Yeah, that's a great question. So I would say before ChatGPT, I would have said more or less do the following. If you have access to a large language model, maybe as your baseline, do some like zero-shot or few-shot learning. You know, if you're thinking about how do you solve a data science project, and then that gives you like a rough idea of performance. And then if you collect some data and label it, then do language like the fine tuning. And the reason I would have said it that way is because like the fine tuning with, you know, a few thousand label examples typically gives you much better performance than few shot. And one of the problems with like few shot has traditionally been that you have to frame the prompt in a certain way. So I don't know if anyone has done this themselves, but last year I worked on a project with this, and it was a nightmare. Like, you know, if you change one word in the prompt, you got different results, and, you know, all of these like metrics that measure performance of models, they usually have very large uncertainty because of that. And so this whole like prompt engineering stuff felt very unsatisfying. And so fine tuning is like typically, you know, the thing you want to do. It requires the least amount of like, you know, screwing around with that. However, ChatGPT and I think GPT-4 changes a little bit the psychology of like what's possible with zero shot, primarily because when you talk to, say, ChatGPT, a lot of the time, the first thing it gives you is quite good. I mean, if you say, how do I do X? How do I do this? You know, it does make mistakes, but it is quite good. And so I feel like the era of like, let's say, fine-tuning language models versus just using like an off-the-shelf API is going to largely depend on like, you know, does your company let you send your data out elsewhere? And, you know, if not, then fine-tuning is probably the thing to do. However, the open source community, I think, has kind of traditionally lagged a bit behind, you know, OpenAI and other companies in producing like very high quality language models. And Llama, I think, is already showing us that, you know, it is possible to get very high quality, sort of decent sized language models. And so this thing about having to use the private API may also not become so important in the next year or so. So to sum up, I would still use like zero shot, few shot as a baseline. But I think for most enterprise applications, fine tuning is probably the way to go if you want to solve a very domain specific task.
Thank you so much for the answer. Really good answer. You touched a little bit on private data. I was wondering if you have any thoughts on the less spoken issues like privacy, ethics, copyright issues. Is HuggingFace working on those issues?
Yeah, so we're working on it on I would say more like a policy side of things. So we don't yet have any like specific tools to help around, you know, privacy and you know, other questions that are important around, you know, sort of like the biases of some of these language models. So on the policy side, we have people like Meg Mitchell. I don't know if people have heard of her. She's a fairly prominent ethics researcher who used to be at Google and is now at HuggingFace. And she leads a lot of the efforts around how do we at HuggingFace set up roughly good practices as a kind of indicator for the community to sort of adopt. And in concrete terms, the way that we think about this is that a lot of the discourse around, let's say, the release of language models is often framed as like, well, our language models are too dangerous. So OpenAI, for example, says their technology is so powerful that if we made it totally accessible, then who knows what would happen. And so the way we're thinking about that at HuggingFace is to think about how do you still retain like open source models, but allow some sort of gating on them so that the people who release the models have some control over its distribution. And this was, partly from Meg as one of her ideas. And around the, like, say, copyright and stuff, that I think is still an unsolved question, in the sense that, like, at HuggingFace, the best we can do is kind of guide other organizations on, for example, Stability worked with us around like the release of Stable Diffusion, and there's a lot of issues around, like, first of all, what does it generate and what was it trained on? And so we usually guide organizations on, like, thinking about, what type of data you may not want to include in the training of your models. And I would say on the privacy side, yet we're not, I would say, doing anything concrete around, like, I don't know if you're thinking about things like, holomorphic, like, encryption and stuff of models, but more like in a general sense, like we're sort of just acting as an advisory role. But yeah, I'm not an expert in that stuff, so as you can probably tell by my answer, it wasn't the most in-depth one.
Well, thank you so much for your answer. I think it's a big field people should consider when they use.
I think that the most important lesson I've learned from sort of interacting with the ethics team at HuggingFace is that a lot of the decisions that you make as an engineer are often focused exclusively on the performance of the model. So you say to yourself, okay, what could I do to make the model better? Okay, I could get this type of data and just throw it in and then, see if it works. And one of the kind of lessons from working with the ethics team has been to have a more considered approach, which is that if you define upfront what are your kind of guiding principles of how you will collect data, it already frames your mind a little bit differently to say, okay, maybe I won't scrape this whole bunch of, sort of dubious content just to get better performance. I should maybe find alternative solutions. And that framing, I think, has been quite helpful internally in terms of trying to think about, not just doing what everyone else does and doing something a bit different.
That makes sense. Thanks. Anyone else have questions? Okay, I'll keep asking then. Things are happening so fast. How do I keep up? Just like so much things are happening every week. It's crazy.
Yeah, tell me about it. So yeah, I don't have any, I think, super actionable advice here. So like everyone, I think we suffer from this now, especially because the rate of progress on many domains is happening incredibly fast. So I think the release of like Stable Diffusion kind of kickstarted this accelerated pace where, every day, if you're on social media, you would see like, the next model being released with, even more images of astronauts riding horses and stuff like this. And I think there's a danger of getting, first of all, like a very bad dose of FOMO and feeling that, like, there's this amazing world of like rapid progress happening and you're, stuck doing, I don't know, Transformers 1.0 and you're like, oh, the world is moving. And the other side of it is that like it's hard to predict where, like, the next thing will happen. And so if you sort of follow the hype, you chase you end up with a problem that you maybe get a very shallow understanding of what's really happening. So my own personal approach has just to ignore it, basically. As in, I picked a domain that I thought I could contribute to, which was this blend of NLP and now reinforcement learning. And that's been my personal focus. And part of that has now involved basically, not looking at Twitter very much and essentially just trying to focus on making my own project work. However, you can't fully ignore stuff because it impacts, the world and your work. And so if you want to keep up, I guess there's a few ways you can do it. One is join a community that is active and, friendly and all those things. And, there are many of them. For example, of course, HuggingFace has its own Discord server. There's lots of people sharing ideas and news. But there's also other ones like Fast AI has a very healthy community, and there you can learn a lot of like deep learning techniques. And the other thing I want to mention is like when I was working as a data scientist, there's like hype stuff you see on Twitter, and then there's reality. And reality is like much more like pragmatic about like, for example, if you're trying to train like a classifier for, classifying documents like inbound requests from customers or something, you may just end up having a much better job by just having like a baseline with like, bag of words and naive Bayes. And this will be far more easy to deploy and debug in production than like, some, 175 billion parameter language model. And so I think there's a tendency of people to say, oh, I have to get the next shiny thing. But being a very good data scientist, in my kind of experience, is being as simple as possible. And so, if that's what your profession is, then I think focusing on those kind of fundamentals is where you have the biggest impact. And so, balancing FOMO versus impact is the hard part. But everyone has to find
I would
their own
make
way.
exactly the same comment. I mean, even though there's a lot of shiny things out there, our problems are kind of old, and we can apply like the current techniques or old techniques and solve them. Like, so
Exactly.
yeah.
Exactly. Yeah, I think one of the most impressive data scientists I ever had the pleasure of working with, he could solve almost all of our problems with SQL. Like he was an SQL wizard, and it was incredible. Like, I was trying to do XGBoost and stuff, and he was like, oh, nah, let's just do SQL. And, I know it sounds like a running joke in data science teams, but it really makes your life less painful when you're not trying to debug like a massive neural network in production.
That is so true. Reality is so different from what's in the Twitter feed and in the news.
Exactly.
Well, do you think what would happen in the next 5 years or even 1 year?
Maybe next month.
Oh, yeah,
5 years
next
is a
month.
very tough question. 5 years.
Yeah. Like, I think what's really hard here, right, is if you had asked me, so for example, right, when we finished the book, we kind of ended with a glimpse of like audio and vision transformers. And if you had asked me, oh, there's going to be this enormous explosion of like diffusion models, I would not have predicted that. Like, it's like a thing where unless you're, one of maybe 10, 100 people in the world who was following that like one research group in Germany, it would have been very hard to predict that. And I think the same is also kind of true for things like ChatGPT in a way. I feel like the technology or the underlying fundamentals of what goes into that, OpenAI has been doing for quite some time, but the interface and the kind of impressive engineering that goes into like serving this to like hundreds of millions of people is the transformative effect. And again, you couldn't have predicted it, right? Like, I think up until ChatGPT, everyone was like, oh yeah, OpenAI, they have these APIs, but like, is it so cool? And now you've got this kind of thing that, when I go in the train, people are speaking about it in German, and like, it's like just crossing languages, right? So I don't want to make any concrete predictions because they'll be wrong. But the kind of, let's say, obvious ones, I think, is this thing I mentioned at the start of progressing towards more modalities. So one of like the very cool things that has, been emerging, especially with diffusion models, is that if you combine, for example, text and images, you can get far more kind of creative expressivity around what you're trying to do. And so I could imagine that, GPT-4 is already kind of multimodal, and we'll start to see, I think, from the open source community, a strong push to, not just train language models, but to train multimodal models. So that's something I think is going to definitely happen. And the other area where I think we might see some interesting progress is around audio and music synthesis. And again, diffusion models, I think, really showed, at least to me, what's possible with like creating synthetic music, just from either text prompts or from other things. You can, almost craft now songs just by saying, give me a song, a rock song in the style of blah, in, about a beach, and then it can generate that, which is quite cool. So those are like the sort of obvious ones. I think the less obvious ones might be around like, what's the ceiling of like capability from scaling up or, adding these extra modalities. So at the moment, you can sort of see that these language models have some rudimentary form of like reasoning. And I mean, okay, you can debate the word reasoning, but they have a rudimentary form of it. And they're also, I think, quite kind of exhibiting rudimentary forms of like theory of mind and stuff like this. And the question is like, will we see in the next 5 years something that like a system that is capable of going beyond this kind of like, I don't know, I give you a question, it gives you an answer, but something that is potentially more like I don't know, that's the word, like can generate its own maybe hypotheses and then test them. And that seems to be so far the thing that's kind of missing of like, when you wake up in the day, usually you say, oh, what am I going to do today? And you have this whole kind of like, imagination of things you can imagine you will do, and then you sort of reason about them. I don't think our language models can do that yet. And that would be, I think, a big change. I mean, if we got to the point where you could do maybe like fundamental science with like language models, that would be, I think, a very big change. And, the rate of progress is so fast, who knows? It could happen in the next 5 years. But anything else I say will just be wrong. So it's probably better not to make predictions on camera.
I love it. I love it. Love it so much. We're out of time. Anyone has burning questions you want to ask?
Yeah, maybe about the reasoning thing, because I'm really interested in this. And I'm sort of transitioning towards sort of transformer-based program synthesis these days, which is almost the same, two sides of the same coin for me, really, like automated theorem proving. And if you can generate programs, you can also generate theorems, because really theorems and programs are the same things. There's this thing called this Curry-Howard correspondence in type theory, and I'm just completely like I'm a bit drowned in this. So many attempts everywhere. I'm not exactly sure where to look at, and I'm not exactly sure what's the actual progress that's been made, because some people are saying, oh, to actually reach reasoning, I mean have good capacity of reasoning for these models. You need to go through the plugin approach, like what we've seen with the ChatGPT plugins, where they can sort of call, I don't know, like theorem provers or set solvers. And some other people are saying, no, you should actually to modify the architecture, and sort of there should be a way to modify the architecture and force the network. It's sort of a neurosymbolic approach, where they say the network should be able to do symbolic reasoning as well. And I don't know. What are your thoughts on this? Have you thought about a little bit about this?
I wouldn't say in any sort of deep sense. I think probably the most, let's say, promising approaches today. So one of the big limitations, right, of language models tends to be that right now the fact that they hallucinate facts and stuff, right? Like you wouldn't want to rely on ChatGPT for like life and death, facts like how do I handle a snake bite or something, maybe it tells you to like suck the blood out or something. And the kind of conventional way of thinking about this is like, okay, maybe then you should couple it to like a database or a search engine or something like this. And that's going in the direction of tools and these plugins. Now, whether that is like, so that definitely assists with for example, fact-based reasoning, in the sense that if you ask someone, you know, who is the president of the US, that they will do some kind of like reasoning lookup, you know, it used to be Donald Trump, now it's Joe Biden.
Yeah.
And these models seem to do something analogous to that. But the sort of deeper question of like, do these models like reason about, say, mathematics in similar ways to us? I think no one really knows like if that's the case. And there's like a lot of interesting work. I guess you may have heard of Tim Gowers. He's a quite famous mathematician who's working on like automated pure improving. And there he sort of talks about the fact that like, even if you have language models that can generate proofs, if those proofs can't be kind of represented in a human intelligible form, they're kind of practically useless for people. And so probably the main challenge here will be figuring out how do you get language models to kind of explain their reasoning in ways that we understand and can make use of, because, and I don't think that's like a really solved problem, but there is one paper I'll share, which I found quite fascinating.
Oh, thank you.
So there's a paper about evaluating GPT-4 from Microsoft, and in this paper they looked at like different elements of like, let's say, reasoning and intelligence of like how you might evaluate things, and one of them that they have is this theory of mind evaluation and also mathematical reasoning. And those you know might be like precursors to thinking about how do we, you know, evaluate these models beyond, you know, the conventional benchmarks and stuff.
Yeah, but the thing that frustrates me about GPT-4 is that they didn't say anything about the architecture. So for me, we're not doing science anymore, right? It's just a product. Like Grammarly, for example, is a product, right?
Yeah, exactly.
So I'm frustrated. I see some benchmarks. It seems to be promising, but I don't know what's going on.
and even worse, right? Like one of the big challenges with all of these like pre-trained models is they often involve scraping the whole internet really in its entirety. And people showed shortly after GPT-4 that like on one of the evaluations, which was like, I think a code, like a kind of loose code type thing, essentially it got like great scores until 2021, and then 2022 it completely failed. And so that shows that the models are being trained on the same data that they're evaluated on. And OpenAI has done usually quite a good job of trying to estimate the contamination between the train and evaluation sets. But even then, at some point, you're not, you know, fully capturing that. And so I guess, yeah, these benchmarks get a bit harder and harder to sustain as, you know, they keep getting scraped.
Yes, that's the thing. That's why some of these results I suspect are red herrings, really, because like especially the math section. So so in the paper I really scoured the paper. I was really geeked out on this for the past few days or so. And the exercise, the math exercise they gave is a classic sort of undergrad exercise. And I'm sure there's a solution on the internet to this exercise. I'm absolutely positive because I could even remember myself the solution of the exercise. So I would suspect there's data contamination when it comes to math abilities for these things.
Although proving the like infinity of primes as a poem is quite nice. I mean,
this is really nice, but as the poem is the impressive thing. The infinity of prime is obviously it's obviously there's thousands of proofs on the internet. That's right. Yeah, no, I agree. That's very but that data contamination is also because I tried on my own. I thought, okay. I tried in an area that's not very well spread on the internet. It's called category theory. I thought, okay, so I checked that GPT-4 knew the definitions I was talking about, and he knew it perfectly. He knew literally the Wikipedia definition, no problem whatsoever. And then I tried to have GPT prove a very simple fact about category theory based on these definitions. But I'm sure, I don't think this fact is I'm not sure, of course, but I don't think it's on the internet because for experts, this fact is called folklore. So it's basically mathematicians don't write these facts on the internet because when you get to the point where you understand the definition, the fact is obvious. Yeah. So nobody would write it because you look like a beginner if you write this on the internet, really. That's it. So I thought, okay, I have to ask folklore questions because then it's sufficiently simple to prove, but it's probably not going to be on the data sets. And he was completely wrong. It was completely wrong. Like the very basic reasoning was absolutely wrong. And And I thought, okay, so maybe actually there's a lot of contamination about the, the traditional sort of benchmark we see on math exams for these things.
Exactly. Yeah, I totally agree. And I think like a future where that is improved significantly, as a former scientist, that would be very cool. Like imagine having like, a lot of the time in research, you talk to people and you have a blackboard and you're writing equations and you're discussing things and stuff like that. And I think having that kind of pair programming, but now it's like a pair
researcher.
Pair researcher. I think that would be very, very powerful. But
it would be amazing.
We're far away from that.
I agree. Like even having heuristics, like I'm not even asking for rigorous proofs because I think it's the job of mathematicians, right? But even heuristics, like having some intuitions. Sometimes the problem, because math is as much an art as it is a science. Like it's really about creativity, and sometimes you just can't think about a creative way of getting out of whatever situation you're in. And I think large language models should be able to help with this. But again, like you can't be too creative. You have to be creative within the bounds of logic. And I think they're really bad at respecting this so far. Mm-hmm.
Awesome. Wow, love your guys' conversation. Fascinating. I'm wondering, Lewis, do you have a few more minutes to answer the final last question from the chat? So smaller companies now prefer API plugins than spending time doing all the other work, I guess. So as an NLP engineer, what areas should we focus on?
Yeah, it's a really good question. So I think the general lessons of like, say, the previous approach versus like, say, potentially this new API-based approach, I don't know. I sort of feel that as long as your business is in a domain that is like sufficiently specialized, the utility of these general purpose APIs is going to perhaps have some limited applicability. And in any case, I think focusing on the quality of the data that is specific to your domain will always be valuable, because even if you have some super duper API, generally speaking, fine-tuning those models on your own data will give you even better performance. So I feel like focusing on those fundamentals around data quality and, how do you measure the performance of the thing you're trying to solve, that's still going to be valuable. I would be surprised if that goes away entirely. And probably as an NLP practitioner, the field is kind of transitioning to an era where hardware is getting commoditized, a bit faster than normal. So today, right, it's kind of, well, let me rephrase it. A few years ago, training BERT was like, oh my God, like impossible, only Google can do that, blah, blah, blah. And you can now train BERT roughly to the same performance as Google, I think for like $30. If you're very clever with like, sort of efficient computing. And so I could imagine that a future where you don't have like a super cluster of GPUs, but you might have like 4 GPUs, but you have a very efficient way of training on those GPUs would be still valuable. So my sort of general thing is like, don't maybe, go all in on APIs yet. It's probably a bit early for that. But really understanding how to do like efficient training. And I think pre-training is probably going to become more commonplace. I might be wrong, but I have a hunch that like, learning how to do this on a decent budget, it will become more common for companies. Because, for example, like in Switzerland, we have like languages that probably don't even exist very well in like, some of these APIs like Swiss German and Romansh and stuff. And again, you could try to hack around it, but eventually you might want to train your own Swiss model if it becomes sufficiently cost effective and, you've got the data for it. So a very, very generic advice, but yeah, just focus on, I think, engineering. I think that will generally serve you well.
I believe even the basic knowledge on NLP can help, because usually your stakeholders, they have no idea how to solve that problem. So if you know the basics, then you can guide and explain it. So yeah, that's one of the things I really found very good about the book, because it gave me so much clarity, gave me so much tools to know address these problems that should be really simple. But yeah, they were not for me because I didn't know how to deal with them. So yeah, I think that's also valuable to know.
Awesome. We're at time. Thank you so much, Lewis. I feel like I've learned so much.
No, thanks for having me. It's been a really fun discussion, and thanks for all the questions. It's a real pleasure when people are super engaged and asking hard stuff. So
Yeah, we love your book. I feel like I need to read it a second time, a third time to fully understand everything. But thank you so much.
I should probably read it one day, because I think after you write a book, you don't want to look at it for a while.
Okay. Yeah, I will post the video online. If anyone feels uncomfortable about showing your face or your voice, please let me know. And Lewis, I will send you the link when the video is up.
Great. Thank you.
Thank
Thank you
so
very
much.
much. Thank you very
Bye.
much,
Thank
Rosie.
you.
Thank you.
Bye.
Thank you.